Yes. Okay, so if you're watching this from the recording, we're just waiting for a few more people to join in. Okay, so less than 2 minutes. Okay, so we have to start so I don't run out of time. Okay, so welcome back to day number 3 of the Intro to Python. All right, so as promised yesterday, we finish up a few things with some functions, and then we move on to something really, really important called lists. In your other languages that you've used, you would refer to those as an array. Okay, so yeah, it's the thing that where things get a little bit more complicated, but these arrays and lists are actually like one of the most critical things. They allow you to solve the problems. Functions allow you to solve really big problems, and yeah, of course, you really tend to use them together. Okay, here we go. Another person. Thank you. All right, so um, here we go. First thing up, a couple of things about functions. I thought it would be very, very important to cover the concept of scope and parameters. Again, the list of things that we've seen or that I've seen people have access or exposure to, like C++ and Java, PHP, and JavaScript, I think were the ones. Yeah, each of these languages have the same concepts of scope. The way how you deal with them is a little bit different. In Python, it's kind of loose, but I mean, it does kind of work. Okay, but of course, you have to be ready for things. Now, there's a few extra things that I wanted to cover in here as well. I wanted to cover a whole bunch of stuff about parameters, and I wanted to cover a whole bunch of stuff about something called a docstring as well, because it's something very important in the world of Python. So what I'm going to be doing is I have like this small example, and we might make a couple of extra functions, but I figured what made the most amount of sense, here we go, is to basically start with this. So here is the example for today's presentation. I will make some changes to it. I might introduce a couple of extra functions as well, just to make things a little bit easier. And I have already gone through and I have typed this in because I have discovered that you can't copy and paste from PowerPoint uh, back into this thing. So I fixed up all the problems. Okay, so I'll tell you where the idea came from for today's exercise. Okay, here, I'll pop this out of here for a second, and I would like to show you one piece of code. Here you go. Here's a little piece of Python code. All right, if you take a look at the Python code right now, there's nothing funny about this. We'll talk about this default parameters in a few minutes, okay? But I just want you to take a look at the format of this. You know, usually when I'm trying to represent code in PowerPoint, I don't like to use things like Calibri formatting or Calibri font because in reality, when you're typing code, everything should be exactly the same size. And something very, very curious happens in the world of um, most of our fonts. Like if you take a look really closely, I mean, you'll say, okay, that's a character right here, that's a character. But notice that this character is quite a bit wider than, say, this character. Yeah, it's called a variable width font. Okay. Here we go. Let me get this out of here. Sorry, I'm clicking on the wrong thing. One thing that I quite often do is I really prefer this font called Courier New. But you'll notice something weird kind of happens when I convert this over the Courier New, everything gets a little bit wider. And yeah, unfortunately, even though it's got the same number of characters in the same line, because the font is a different format, it turns out to be a little bit wider. Okay, so that was my inspiration for this function right here, calculate the width of the text. So the idea was given a piece of text and a font size and a font type, is it Calibri or is it Courier? Sorry, this says Times New Roman, but I got rid of that one. It will tell you how many pixels wide it is. Okay, it's not really a number of pixels, but in any case, it's going to be something based on number of pixels or maybe inches or something else. And of course, you'll notice that Courier is a little bit wider than Calibri. That was the whole idea. I wanted to keep this as simple as possible. All right, so there you go. And at the same time, I thought, okay, if we've got something for calculating the text width, maybe I need something pretty simple for calculating the line count. So given a big long piece of text in a 12-point font, how many lines of text do you require? And this all comes back to exactly the same thing here. If your thing is kind of narrow, obviously you're going to need more lines of text. If it's really, really wide, well, you don't need quite as many. Okay, that's what these two things are about. So we'll come back, we'll use these. I'm going to describe these as being real legitimate functions. Some of the things I'm about to do here today might be a little bit, I'm going to call them fake, because I don't really see like how you'd use them. However, I want to include some of them because sometimes it makes life just a little bit easier. Please ignore that help for a minute. I will be back and we will cover that. All right, now, word of caution about today's. Normally, I go through and I make up very detailed timing, so I know exactly where I'm supposed to be at different times, and I didn't do that for today's slides. So I will stop when we reach about 4:50. Okay, might go a couple of minutes longer, but hopefully I'm able to get through all of the slides. All right, so I've got a bunch of functions in here that we're going to be using just to give you an idea about how they look. Okay, so here we go. R is equal to calculate text width. All right, and what you would do is you'd say, okay, here's a string. So here is some text. The second parameter is the font size. So we'll say 12. Just ignore those equals 12s up there yet. And we'll say if it would happen to be Courier, which is my favorite one. And if I print R and I run the application, it comes up and it says it's 122. 122 what? I don't know, millimeters, pixels. I'm not really sure. It doesn't matter. But of course, the idea is that if you double up the size of the font, it's probably going to be twice the size. Okay, so there you go. That's it. I've got something in here that if you try to ask for curries, it just comes back and it says unsupported font type. I suppose it shouldn't say Times New Roman. It should say Calibri. Okay, just put that in so it's more consistent. All right, that's one of them. The second one is estimate the number of lines. So let's call it some text and we'll say this is some long text with a lot of blah, 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 blah. Okay, and what I'm going to do is I'm going to say R is equal to estimate line count. And the text is just called text and the font size at 12. And I'll print R just so we can see it. And it says, I misspelled something. Let me try that again. And it says it's going to take 7 lines of text. Okay, again, whatever that means. I'm not actually trying to model anything, but basically the idea is, okay, you have a rectangle. How many lines are we going to need to fill this out with this text? All right, so fine. Those are the two functions. We will use them. We'll make a few modifications to them. But let's get back over to the slides for a minute so we can see what I put in here. Okay, and up here. And the first thing that I have to cover about this is I have to cover the concept of variable scope. Okay, variable scope means where a variable can be accessed. Okay, so what do you mean where can they be accessed? Okay, we're talking about functions. Now, what I'm going to do is I'm going to put this one away for a couple of minutes and I'm going to just put a bunch of blank lines just so we're not confused by this. And I am going to define a function. Remember we had one yesterday called make latte. All right, and I believe that we had a parameter called num cups. All right, and if I remember one thing, we had let's see, trying to remember. Okay, we had some water, and I think it was like 110 mils per number of cups. All right, so there you go. The amount of water is equal to this. Now, I can obviously print the amount of water. So if I say make latte, and latte, not make late, two things, yeah, it'll be 220 mils of water. Now, really, I should have something else in here. Maybe I should be returning something. In fact, let's do that. You will need water mil of water. There you go. And one of those, there you go. So you'll need this many for the 2 cups. Okay, perfect. Now, here's the thing that I want to do, however, is can I just say down here, print water? And in other words, I call make latte, and you see inside here, I've created a variable and set it equal to 110 times the number of cups. Can't I just print water right here? Obviously, we can print it inside the function, but the question here becomes, can I print it outside the function? Okay, let me see. Okay, here we go. Okay, let me see. Let's see. Okay, excellent. No, no, 1, 2, 3, 4, 5 people. 1, 2, 3, 4, 5 people. Okay, got that up to date. All right, so here's my question is, do I have access to that thing called water? And the answer is a resounding no, I don't. Okay, why can't I print water from here? The reason why I can't print water from here is because this is the main, and I use main in quotes because we don't actually have a main function, but when you declare variables inside a function, they are locally scoped, and as soon as the function is finished, the variables that you declared inside the function get removed. And you would have to call the function first, as is local to the function. Okay, so you're absolutely right. Okay, now but you'll notice that I am calling the function because I'm calling the function on line 35. Okay, so I have called a function. Now I have to remind you about the process about how functions actually work. You see, if I were to run this program, we actually go through this in our INFS 1101 course quite a bit. You say, okay, what's the first thing that gets executed in this program? Just pretend everything else is blank because we're not dealing with it at the moment. You see, the first thing that would happen is it defines a function. Now, when you define a function, that doesn't execute the function. That simply says, oh, by the way, if you need a function, here's the code. So in other words, this doesn't execute. The very first line that happens is line 35. When the interpreter reaches line number 35, it immediately jumps up to line number 31. And at that point, it will then work its way through. It will create a variable called water, but this is a local variable. Okay, I can use it inside the function, but at the end of the function, so on line, as soon as I'm finished my print statement on line 33, I return back to line number 35, and of course carry on with line number 36. Now, if you want to really check this thing, I did find something quite a few years ago called the Python Visualizer online. I find this is a very, very helpful little tool, especially when I'm covering variable scoping. So, sorry, I probably should have included this, but here we go. We're going to visualize this thing, and sorry, it's you can see right here, it actually doesn't work. Let me get rid of this line and visualize this. Okay, here we go. What we're looking at is a visualization. So the very first thing that happens is I define a function. Notice that I just defined a function. I don't actually step through the code inside. But what I will do next is I will make a jump up to here, make latte, and of course the value called num cups, well, num cups is now equal to 2. All right, I go through here, and the very next line creates a brand new variable called water. Okay, that's fine. I make a print, but then the very next statement, I come down here, and you'll notice that the local variable disappeared. I no longer have water. Oh, I no longer have something called numCups either. All right, so yes, numCups works just like local variables. At the end of the function, they all go away. Every language you guys have talked to me about this, JavaScript, PHP, C++, and Java, with the exception of some weirdness with JavaScript, yes, variables that you declare inside a function go away at the end of the function. So in other words, if you want to send something into a function, you use a parameter. If you want something back, you use a return. You can't modify a variable from inside. Okay, so it's sort of a very important thing. So yes, even though we are calling the function, the variable is only temporary and it does go away. It's called a local variable. Okay, let's get back over to here. So variables created inside a function are called local variables. Variables defined outside any function are called global variables. Ooh, okay, so now what we need is we need to have another variable. Okay, so I'm going to just make up this random looking thing. I'm going to call it milk, and I'm going to set milk equal to 200 for some reason. All right, clearly, if I say this, okay, if I try running this program, let me get rid of this print water because you know it doesn't work. Will I actually see a message or will I have a problem? And the issue is, yeah, of course it ends up working. Okay, perfect. That's fine. But now, here is my question. If I remove this and I put it inside the function, do I have an issue or do I have access to it? Well, it turns out I actually have access to the variable. Because this variable was declared outside of a function, it is considered a global variable. Global variables exist all the time. Okay, so there you go. Global variables exist all the time. All right, so what you can do is instead of passing in a parameter, you can actually set a global variable. Well, you could do that. You shouldn't do it, but you could do this. And again, most of those languages that we've seen, the C++, Java, PHP, and JavaScript, they all work exactly the same idea. Variables declared inside a function are generally local. Variables outside are global. Now, there's going to be lots of things about when we shouldn't be using globals, but here we go. We start off with the local ones. So variables inside functions are temporary. Okay, cars per line, num lines, total width are examples. Let's go back and take a look up here. You see right here, total width. Total width is defined right here. That's a local variable. Okay, fine enough. What about text? Well, text is a parameter. It kind of acts like a local variable. In other words, if you come down here and you try to do something with text, it doesn't work. The same is true with font size and font type. All of these things are local variables. Inside the function called estimate line count, that's essentially a local. That's essentially a local. Um, Guess what? That's something different. We'll have to explain that one in a second. That's a local variable. That's a local variable. So in other words, if I call estimate line count, I will never have access to num lines. I will have access to what was returned, but I won't have access to this variable here. Okay, because I can take whatever was returned and store it into a variable and use it. All right, so variable scoping, very, very important. Yes, the way how you get data into a function is by parameters. The way how you get it back is by a return. But there is this weird little keyword that I tossed in called global. We'll get to that in a minute. All right, so local variables disappear when the function returns. Okay, you can't access any local variables from any other function. Okay, so even if, okay, here we go. If make okay okay, cappuccino. I don't actually know very many types of coffees. I sometimes get cappuccino, and I'm going to ask the question, do we have access to water here? And so I make a latte, then I'm going to make a cappuccino. I don't know if I'm spelling that correctly. And we'll make two of those. When I try to run this, I have exactly the same issue. It says here that water is not defined on line 37 right here. That's because this is a local variable from somewhere else. Do I have access to milk? MILK. And the answer is yes, I do have access to milk because milk is a global variable. See, pretty straightforward. All right, local variables. You can't access any local variables from another function or from the main. Parameters are essentially local variables, and modifying a parameter may or may not modify the value in the caller. Oh, sorry, I don't like this one, but I have to cover it. Okay, let's see. Let's have something called cups, which is equal to 2. All right, I'm going to print cups. I hope you're quite aware that that is going to print the value 2. Okay, here, I'll run it right now. It's going to print 2. It's not a trick question. I'm going to make a latte. I'm going to make a latte with cups, and then I'm going to print cups. All right, so just kind of putting together these silly little applications. Okay, so all that I'm doing right here is I've got a variable. It's a global variable called cups. I am printing it. I definitely see 2. We saw it a second ago. Next, what I'm going to do is I'm going to make a latte. And when I make a function call with cups, num cups will pick up the value of cups. So in other words, num cups will be 2. I'm going to print out my stuff with the water and the milk. Oh, sorry, we have to remove the milk stuff because I don't have a variable anymore. And then I'm going to print out cups. And here's the question. We know this is 2. What's the value here? Well, I mean, we never change anything, so I expect 2. Okay, yeah, I've got the extra print statement for the amount of water. That's fine. Here's what I want to do. Num cups is now equal to 100. Okay, here is my question. When I run this program, remember, programs run from top to bottom. It's one statement at a time. Of course, when you make a function call, you jump into the function. All right, we set the variable called cups is equal to 2. We print cups to the screen. Okay, perfect. That's 2. We call make latte with 2. We jump up to here. We calculate the amount of water. Okay, num cups is 2. So I expect 220 mils of water, followed by everything else. And then I do something really weird. I say num cups is equal to 100. All right, then my function jumps back to here and I print cups. And my question is, what gets printed? And you know, there are 2 possible answers that you might jump at. The first answer is you may say, well, it's just 2 because I never modified cups. Okay. Another thing, however, that some people may look at, they may look at that and go, well, it's actually 100 because, well, although we didn't modify cups, I modified num cups. Num cups was the parameter, and this is what got passed in. Okay, well, I don't know if we want to call it good news or bad news. I think it's probably good news. When you run something like this, you are not modifying the parameters. All right. And this is the way how programming languages like JavaScript and Java work. C++, on the other hand, okay, you'll have to give me a second because I don't have anything open for C++, but here, for people who've been through here, make latte int num cups. Okay, there you go. This is how you deal with this. And in the world of C++, if you said num cups is equal to 100, that would not change whatever was passed in. However, those who've been through and you've learned a little bit of stuff about C++, I am quite sure that you probably learned about the ampersand, and what that is, that makes something a pass by reference. And if you put an ampersand here and you modify this, then you're actually modifying the thing in the outside. Okay, so don't worry about that. If you've never seen C++, I'm just putting in the context for whoever said that they've seen some C++ before. That is what you would do to allow a function to modify things. That was called call by reference, and without this, it was called call by value. You'd have to be very careful if you use this because one of the things that you don't want is you don't want your functions making these changes. There is no such thing as call by reference. Oh, sorry, there is. In the world of Python. In the world of Python, things are either call by value or call by reference, and it all depends on another concept, which we haven't covered yet. But I think we'll probably see it. It might be the very last lecture of the day, or it will be the very first one of tomorrow. And I will show you how you can actually modify these parameters, but you require a slightly different type. All right, so in any case, if you modify a parameter, it has no impact on the variable in the main program. That's what we're trying to talk about. It is possible to change it, but I need to talk about something called mutability, and we don't have anything that's mutable yet. All right, so here we go. Now, Okay, let me put this away because I want to go back and I want to start talking about the other things. All right. Here we go. Make the latte. Num cups. Okay. I would like to go back and I would like to set, let's see if we can get this all put in place. MILK is equal to 200. I'm going to say, oh, I've erased too much stuff. Make latte, 2 cups, print, print milk. All right. All right, now here is something new and completely different and very, very disturbing. All right, milk. Is it a global variable or a local variable? Okay, well, we know very well what we've been talking about. Um, well, it's supposed to be a global variable, right? Because it's declared down here. But hang on, is that a declaration? This seems a little strange. All right, so here's what's going to happen. Line 37 happens first. I'm going to modify, I'm going to create a variable called milk. It's going to be equal to 200. Excellent. I'm going to call make latte. I jump inside the function. I calculate the amount of water, whatever. I print it. The question becomes is, if I change it here, am I changing it here? You already know if I print, here we go, inside function, Wilk, milk. It's a combination of milk and water. Okay, here we go. If I call this one, that is definitely going to print to 200. But the question is when I get back here, what am I going to see? Am I going to see 200 or 10? All right, let's find out what happens. Ooh, we've got a bit of a problem. Okay, we have got an error that says unbound local error cannot access local variable milk where it is not associated with a value. This was a problem on line 34. So what happened is I tried to access milk, but what happened is Python looked and it said, you know what? There's a local variable called milk, and you haven't set it equal to anything yet. Ugh. Okay, let's get rid of this line. Okay, maybe it's just a line. I mean, this is what we do when things don't work, you erase it. All right, take a look at this. When I run this might not be what you were expecting because you saw that milk was supposed to be a global variable. How come it didn't change? Okay, well, unfortunately, in the world of Python, um, you can look at a global variable with a print, but you can never modify a global variable unless you include a magic statement called global followed by the variable name. Okay, now you could probably put this just about anywhere, but I always put my global variable definitions at the front. That's where I like to define my variables at the start of functions rather than just midway through. But you see, this now does what we just expected. Okay, this statement right here, this statement combined with this statement is telling Python the variable called milk is global, and that's the one I want you to change. Not the local one, but the global one. Okay, so this becomes really important. If you want global variables, you really need to put in this word. All right, now take a look at what I've done up here. This was the original program. All right, so do we see any global variables? Yeah, here on line number 25, I've got a global variable called page width. Page width was something defined up here. It was 100 characters or something. And what I decided to do was I said, well, when you want access to this variable called page width, look here globally, but I could have also said right here, page width, and I could have passed it in as an extra parameter, but I didn't. Instead, I ended up using a global variable. Why did I do that? Okay, I've got one word for you, laziness. Ooh, yeah, and honestly, that's it. I was being lazy. I mean, I did it on purpose, but honestly, I was being lazy. That's usually what ends up happening with the world of global variables. It's because people were lazy. They didn't want to put an extra page with here, and they didn't, when they called it, they didn't want to pass in an extra parameter. That's what ends up happening. So hang on, laziness. I mean, we shouldn't be having laziness, right? I remember seeing once something where they described this as the seven deadly sins. I don't think it had something to do with programming, but laziness was one of them. Okay, which is kind of funny. But yeah, it usually does cause you trouble. Okay, why do we have problems with global variables? Okay, here is one of the issues about a global variable. You see, remember, functions are not just 2 or 3 lines, they're usually pretty big. Okay. And let's suppose I accidentally modify one of the variables and I would just want to do a line count estimate. Okay, so here we go. R is equal to estimate, line count. All right, I'm going to pass in some text. There you go. There's some text, and the font size is 5. Okay, don't worry about that word that says equals 12. We'll get to that. Print R. Okay, fine. So it comes up, it's one line. You know what? Just let me put in a couple of extra statements. Here you go. Now it's 2 lines. Excellent. But you see, here's the issue. Okay, just before I'm going to print the page width. All right, the page width is 100. After I call the function, what happens to the page width? Well, now the page width is 10. That, my friends, is called a side effect. I called a function estimate line count, and it went and modified a variable that I wasn't expecting. This is generally a very, very, very bad idea because you can imagine a really, really big program. If you're using many global variables, you call a function and suddenly your variable name or your variable values get changed. This is really not what you want because the reason why you write your function in the first place is to keep everything as simple as possible to make it easy to put together your programs, understand what's going on. Modifying a global variable, I'm going to describe that as this is kind of like the worst thing that you could do. Using a global variable, just looking at its value, okay, it's not great, but you know what? You can get away with it. Modifying global variables, yeah, I really kind of suggest that you avoid that one. That is going to cause you an enormous amount of hurt. And the person getting hurt is going to be you, right? Because what will happen is you'll write a function and you'll call a function, and suddenly you've got different things appearing in other variables that you don't understand why they're changing. I have solved lots and lots of problems after many, many hours because of what people have put in as global variables. I don't mean student code, but I'm talking like real honest to goodness stuff. Okay, that system that I worked on before, I've talked about it was about 100,000 lines of code, and we actually had a global variable called S. It was impossible to track down. It was causing all kinds of conflicts. Took me many years to find where the variable S was. Okay, eventually, once I found it, I told somebody to go through and actually fix it just to make it a little bit longer so it was easier to track down. For some reason, whoever wrote the piece of code decided they needed S to be a global variable. And I'm sure it made sense at the time, but it just kind of spiral out of control. I'm sure they had just a small test piece of code, and the test piece of code got into production, and then suddenly you've got like real live code, and you have no idea what it means. All right, so parameter modification. So my parameter modification, okay. Parameter modification. What I'm talking about here is I tried to modify this font size to be 99, and yeah, I've already demonstrated this. If you call where size is equal to 10, just because you modify the parameter doesn't modify the actual argument that was passed in. Okay, global variables. So global variables, yeah, we've talked a lot about these things. So just me remember or remind myself what I think I've just said. So these are variables that can be accessed and modified from anywhere. Modifying a global variable is usually a bad practice. It's called a side effect. To access, you should include the global keyword. You don't actually need it if you're just looking at it, but I recommend that you always put the word global if something is expected to be global. You don't need it if you're looking at something, but it's a good practice. And of course, global should be avoided. If your function needs something, pass it as a parameter. If it needs to send something back, send it back as a return. Done. So global variables can really make large programs difficult to maintain because you just have no idea what's coming. All right, I got something new up here that I haven't really covered yet, and I've said a few times, yeah, just ignore it, just ignore it, just ignore it, just ignore it. All right, I'm going to pick the estimated line count. Here we go. So here's the estimated line count. How many parameters does my function have? My function has two parameters called text and it has font size. All right, what it ends up doing, oh, it's also using this global variable. Yeah, that's fine, we'll use it. The first one is text, the second one is font size, and you'll notice something really bizarre. I've included an equals 12 at the end. All right, but in any case, before we get to that, how many parameters does my function have? My function has Okay, so thank you. So why is a global variable should be avoided? All right, so remember what I just said. When I had this line in here, I said that the page width is equal to 23. This is the reason why I don't like this, okay? You see, if I call print the width, I'm going to see the value 100. I'm calling estimate line count. Okay, and I'm going to get back a line count. It's going to be 2. But then when I run this program, you'll notice suddenly that the page width has now changed to 23. That is something that I wasn't expecting because this function is called tell me how many lines it's going to be. It's not called estimate the number of lines and then modify the line count to be 23. I mean, if you want that, we could give it that name. Because that was kind of an unexpected, just based on estimate the line count, it's considered a side effect. You don't want global variables being changed unexpectedly. Now, if it's very, very clear what it's doing, it might be okay. For example, if my function was called change page width and I said 23, I would probably be okay without actually changing the width. Okay, now for this, I'm going to have to write a function. Here we go. So let's write the function change page width. Okay, so new width. And all I'm going to do is I'm going to say, yes, I've got this global called page width. And I'm going to say that the page width is now equal to the new width. Okay, there we go. So that actually changes it. And that's fine. Okay, this is sort of okay. Okay, notice what I said. It's sort of okay. Yeah, it's actually it would be the way. If I do have a variable, a global variable called change width, yeah, I might write a function called change page width that actually deals with this as a global variable. In this case, you'd have absolutely no choice. But perhaps a better way is not to use a global variable in the first place, because then you wouldn't have side effects. Okay, but change page width, at least it's something I'm expecting. Okay, and so the question might be then, okay, so Mr. Hotshot, we're talking about things. Do you follow your own advice? Okay, let's find out if I follow my own advice. I'm not ashamed to open one of these up and say, yeah, let's look at it. Let's see, new window. Here we go. So remember, this is this big long program that I had before. Okay, I got some global variables called the interest lists. And okay, local variable, local variables, local variables. Hey, do you see the word global? Actually, I don't really see the word global. DS name, it's a local. Ooh, hey, look at that. I'm following my advice. Do I always do it? And I'm going to give you a very straightforward answer. No. Okay, here you go. I just caught myself with one. Okay, see the variable right here called MyDB? That's a MySQL database. You can see I haven't declared it as a global, but it's right up here and it is a global. Oops. Do you know really what I should be doing? I should have done right here, global my DB. I should have done that. Okay. I also had something here called batch number. Okay. Now, why did I do that? Okay. I have my reasons for calling batch number. It actually needed to retain its value across different function calls. That's another reason why you might want to use one. I don't quite have enough time to explain why you'd want to do something like this. But yeah, you can see sometimes I do need global variables. So no, it isn't like, ooh, you should never do it, or you can never do it. You just have to be very careful about what it is that you're doing. So why did I make the MyDB global? Because I was lazy. I already had 3 parameters. Okay, I'll fess up to that one. That was complete laziness. Why do I have batch numbers as a global? Okay, a very, very different reason for that one. Okay, maybe during the break, if I can make something I can probably put something together. Okay, if I get a couple of minutes at the end, let me put together an example that's based very similar to what I've done here. All right, so you see, sometimes people who actually tell you one thing sometimes do something a little bit different. Okay, and yeah, programmers, by the way, are incredibly lazy. I always tell students, why would you do something like this? And the answer is almost always, yeah, people are just being lazy. Okay, all right, so that's the reason why we kind of want to try to avoid global variables unless you need them. because you're trying to modify something, well, then obviously you have to. Or maybe you're just trying to reduce the number of parameters that go in. Okay, again, kind of laziness because it really is just typing. But there's going to be maybe a couple of other cases where you want to retain a value for another time. Okay, now, yeah, let me finish the slides first, and then I will come up with an example. I think we will have the right amount of time. Okay, here we go. So those are the global variables. So here's the problem. They can make the programs kind of difficult. So my recommendation is just avoid it. Okay, it's pretty simple. Avoid it unless you absolutely need it. And most of the time, you probably don't need it. All right. Sorry, I have to get back over to this one. All right. All right. This estimate line count. Oh, I forgot what I was up to. I had this done already and I got distracted, but that's okay. I don't mind. Estimate line count. Okay, here we go. Here's a bunch of text, and the font size, of course, required is 34, and I'm going to print R, and it gives me some number. Okay, fine. It's something. It's 34-point font. Now, I'm going to ask the question, what happens if I don't pass in that parameter? Now, for most of your languages. Okay, so I'm trying to remember now. I know that PHP contains the concept, but I honestly can't remember C++. I guess it's been too long. JavaScript and Java kind of also, or PHP and JavaScript, I think do. But in any case, if I try running this program actually continues to work, which is very, very strange because there's supposed to be two arguments passed in because there are two parameters. Well, here's what happens. Because I said font size is equal to 12, if I don't pass in a font size, it automatically assumes the font size is 12. Like, for example, if I pick a 12 right here, I'll get exactly the same answer because it's exactly the same thing. If I put in a different number, of course, I would get a different calculation. So what this is simply a default value. This is incredibly, incredibly important. I did say that you guys will, or many of you will probably go off and you'll have to do the course on data science and artificial intelligence. In the documentation, you will find a lot of functions that have default parameters. And what you can do is you can specify some things, but not the others. But here's another one that's also kind of weird. Okay, and it's something, again, I know we can do this in Python, and I just, I know we can't do this in C++, at least from what I remember, unless it's something new. And I don't think the other languages support it, but what if I just said the font size is equal to 10 and the text is equal to hello? Yeah, that's actually allowed. What it will allow me to do is I can pass things in any order that I want. I just have to specify which size. Now, we've actually seen things like this already. Remember this? If I said print 12, 34, and 56, what goes between everything? Well, exactly a space. But what I can do is I can say that the separator is equal to an X, and what it will do is it'll stick X's between them. This is specifying the separator. The default value is a space. Okay, that's exactly what it is. So if I don't say what the separator is, it's automatically a space. And that's kind of cool. Okay. Sometimes it can really make calling functions a little bit easier because you might not have to pass everything in. A lot of the functions that you will see in your DSAI type courses, you'll find that functions will have like maybe 10, 15 parameters, and maybe you're only interested in passing in one or two of them. So that's the reason why you may say something like X is equal to 56 and blah, blah, blah. Obviously, it's not going to work here because print doesn't have one. Now, there was an extra thing as well. Okay, so there's a default parameter. I've got a different one. I've got this other thing in here I'd like to include. Okay, notice that I've got a function, and inside the function, I put a triple quoted string as the very first line, and I did it here as well. Okay, now, what is that? I mean, this is a string. Okay, here's the secret. Strings in the world of Python are completely ignored. And a triple quoted string simply means it's a multi-line string. If I don't store it into a variable, it actually kind of works like a comment. So if you are used to in other programming languages having like multi-line things that look like this for comments, and you need to do the same thing here, it's actually a triple quoted string. Like for example, if I wanted to comment out those two functions, this is exactly what I would do. I am calling this an abuse because this is not what it was designed for. It just happens to be a way that you can comment things out. Now, this very first string that shows up inside a function actually has a name. The name is called, I'll write it up here just above, hash docstring. Okay, it's called a docstring. What it is, it's a description of what the function does. Oh, it's a comment. Yeah, it's a comment describing the function does the following things. Okay, now that's great. Who cares? All right, well, here's where it can be useful. There's a really cool little application or function called help. All right, and take a look at this. If you need some help about the print statement, you can say help and you can pass in the name of the function. You don't call it, okay, it's not like that, but you just give the name of the function and, sorry, when you run this, see what it does? This is help on built-in functions. And here it is, that's the print function. So the print function takes a whole bunch of arguments. It takes a separator, which is a space by default. At the end, it will put a new line character. And if you don't specify, it will be this. It reads or prints nothing or prints to no file. We never covered files. We don't cover it here. And there's also this thing called flush, which again has to do with file management stuff. That's about print statement. Hey, what else do we have? Well, we had a function called str. Remember, we talked about taking str of a variable like this. Okay, what this is, this will give you all of the information about what you can do about the str class. Like, for example, okay, some of these all right, if you've been through object-oriented programming, yes, you know that this is a class with an object, but down here are going to be kind of the interesting functions like capitalize, case fold, center, count. Now, we saw a couple of these things. We saw, for example, you can read through all of these to see what we've got. I'm just trying to find one that we actually covered. And here's one that we covered called dot lower. And what it does is it returns a copy of the string converted to lowercase. So usually what I get in class or in my intro programming courses, a student will say, do we have to memorize all these functions? And I say, no, you don't, but you do know how, you have to know how to go and ask for help about it. Oh, everything else. Yeah, the word int has got one. Okay, so here you go. We had another function called length. What does it do? Returns a number of items in a container, whatever a container happens to be. In fact, I think you can even ask for help on help. Okay, and if you want to, you can even just ask help altogether, and it gives you some kind of an interactive thing where you're supposed to be able to type things. Unfortunately, this little interpreter that I have doesn't work. Oh, well, that's better than usual. There you go. There's some symbols. Okay, maybe keywords. Okay, so some things are useful. Class. Okay. Some things I'm supposed to be able to type class and it's supposed to give me some information about class, but some things work, some things don't. Okay. Use it as you use it at your own risk. But help about estimate line count. Copy this, paste this. Take a look at this. Oops, sorry. Terminate that. Sorry, that's the problem. Get into an infinite loop. All right, take a look at this. When I say ask for help on estimate line count, it actually prints out exactly what I put in here. So it's very, very useful if you're trying to build up like a dictionary that you can use, and it has a bunch of functions in it. You want the user to be able to find out what the functions do. Like for example, help on math. Okay, well you have to import the math library first. Sorry, import math, bang, and you get a list of all of the math functions. So again, very, very useful. Okay, but in any case, it's here. It's to your advantage if you happen to have access a to an interpreter, then you can just type help and bring up all kinds of info. All right, I've got one extra thing that I would like to do. I hope I am not destroying anything, and I am going to call this display line. I'm going to take some text. Okay, and all that I'm going to do is I'm just going to say, here is the text. Very, very boring little application or very, very boring little function. So I'm going to say display a line and I'm going to say one. Bang, you run it and it says, here's the text one. I'm going to say display line two. How are we doing? 1 minute, 1 minute. I think we'll probably do it. All right, and display line help. Here you go. So here's the text, here's the text, here's the text. Instead of just saying here's the text, I want to say this is line number one. This is line number two. This is line number three, help. Ooh, how are we going to do this? Okay, well, what we would need is you to say this is line, and I'm going to have a variable called line number. Bang. Oh, line number is not defined. Okay, line number is equal to one, run it. This is line one. This is line number two, or sorry, line number one, two. No, I want this to go from one to two to three to four. Now, if somebody says, well, the line number just needs to be the line number plus one, unfortunately, that doesn't do anything. I'm sorry to saying, there we go. Apple, here, not dog, I have a cat. Have more cats. Here we go. Apple, cat, and help. Line number one, line number. Remember, this is a local variable. It goes away at the end of the function. And then when you come back in, line number one becomes one again. Okay. So you might say, well, what if I just get rid of this? Okay, well, you can't do that because I can't print it because it doesn't have anything. The way how you would solve this problem is you'd have a global variable called line number, which you'd set equal to one, and you would say, over here, global line number. Okay, now take a look at this. When you run this, I get exactly the 1, 2, 3, because what happens is line number now gets remembered between function calls. So if you have a variable that needs to be remembered from one function call to the next, this is how you do it. Okay, you declare a global variable and you simply say there's a global variable, and now you can do whatever you want with the global variable. And when your function calls it, your global variable changes. Now, as usual, there's some positives to this and some negatives. The negatives are these things are really hard to write parallel programs, but as long as you kind of keep it very, very clear about what it is that you're doing, and you would have to include probably a doc string to explain that this modifies the line number variable, blah, 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 then it's not so bad. So you just make it very, very clear what's happening. Okay, perfect. So that was the very last slide that I've got to cover for the first hour. Okay, so I ended up with like 2 minutes longer than expected. So here we go at YouTube. Bang. All right, I can see that most of you have ended up in getting yourself into the D2L. So if I know that I think I saw one or two students still had not. What you need to do is you need to go to the following website, password.udst.edu.qa. Okay, and you end up with a password reset. What you do is you stick in your ID with at udst.edu.qa, follow the prompts, and you will be able to reset your password. Once you have that set up, then you can go to the place called d2l.udst.edu.qa, and you should have access to it. Okay, so if you didn't get logged in yesterday, this is now something I want you to do. So let me put this one back. So it's right here. It's password reset. I never remember this one. I call it password.udst.edu.qa. Okay. All right. So let's see this one. And here is our 10-minute timer. All right. So when the time reaches zero, then what we'll do is we'll start off with section number two. Okay. So take a break from your ears from my voice, and I will also take a break. Okay, well, according to the description, it says a police siren sounds to alert you time is up. So I just want to hear what it sounds like. Okay, then we'll begin. Okay, I guess it sounds like a police. All right, excellent. Let's get back over to here. Let's clean this up and let me get over to the next set of slides. Okay, here we go. Lecture number 8. So for the next 50 minutes, so actually it's going to be a little longer than 50 minutes because even the next slideshow is also related to it, although I see a mistake on the first page. Nice. In any case, list basics. Okay. Um, for those who have been in a lot of other programming languages, we're talking about things called arrays. Okay, in other words, the things with the square brackets. Yes, this is what we're talking about. Okay, arrays, lists in any language are really, really, really critical building blocks because we often end up with situations where we have to have a whole bunch of data that we need the process to store and to be able to regurgitate and do calculations with. And yeah, lists are the way to deal with it. Lists were not invented to make programming courses really hard, although I think my intro programming students probably think that that's a lie because everybody finds it kind of tricky because, well, it is tricky. Okay. But in any case, here we go. Let's get off and started on this. So, you have seen, since you've been involved with programming before, hopefully you have seen lists. So really, this should be a reminder of things, but hey, that's all right. So here's the introduction. This is like the bridge in that I would normally do in a typical course. I'd say, okay, if you wanted to hang on to 3 test scores, no problem. You would probably define 3 variables called test 1, test 2, test 3. And of course, well, you can put things, different values in here. Perfect. You have 3 test scores. But what if you had 100 of them? Okay, now I know what you'll say is like, well, okay, no problem. I'll just copy and paste it another 97 times. Okay, remember I've said what I've said about copying and pasting before. If you find yourself copying and pasting something more than once, chances are there's probably a better way to deal with it. And although you could have 100 variables, it's not that useful. Okay, because maybe you actually don't know how many variables you're supposed to have. Maybe you're supposed to have 50 sometimes and 100 in other cases. Like for example, when we run courses, if I ask you how many test scores we have, okay, well in this course, like for today, right now, there's only 4 people. So no problem. I get away with test 1, test 2, test 3, test 4. However, during the regular semester in my intro Python course, we usually have about 400 students across multiple sections. And no, we're not going to have test 1, test 2, test 3, all the way up to test 399, test 400. No, it doesn't work this way because the size of our code simply becomes too much. All right, so what is a list? Okay, as I said, you have certainly seen the word arrays before. What a list is, it's an ordered collection of items. What does this mean? I've got new words in here. I got the word collection, I've got the word items, and somebody's included the word ordered. Okay, what this means is okay, so first of all, we'll pick up the word collection. The word collection means that you have more than one thing. Okay, that's what it means. And you can even see that I've got a small example there, but I'm going to write it over here and then we'll talk about the others. So here we go. Instead of having test 1, test 2, test 3, I'm going to have this variable called test scores. And all that I'm going to do is I'm going to list a whole bunch of them. So here we go. There's a test score. There's a test score. Sorry, with a comma. Here's another test score. We better have a better grade than that. Here we go. And if I ask you, how many test scores is this? I hope you'll look at that and you'll say, oh, well, of course it makes sense. It's got 4 test scores. Okay, and yeah, and that's exactly it. But how many variables do I have? Well, the good news is I only have one variable. So I've got one variable storing 4 different things at exactly the same time. Now that is incredibly, incredibly useful because instead of having 100 variables, I only have one. But I have 4 different variables. And even if I had 100, I still only have one variable. Now, here we go. Print test scores. Now, how do you go and you pull out the individual scores? It looks very, very suspiciously just like what happens in the world of strings. You use indexing. Okay, so here you go. If I say test scores and I ask for square bracket 0, what that's doing is that's going to pull off exactly the first score. If I wanted the 67, well, that's at the next position right here. If I wanted the very last one, that could be listed as position number 3, or if you want, you could even use position number -1, and it works just like pulling out characters out of a string. Okay, so at least there's something that's a little bit familiar, because if we've seen this in strings, it shouldn't be too bad. Now, we have a couple of big surprises about this, which do appear in the world of Python. All right, for those in Java or C, C++, or even, let me see, yes, even PHP, you'll have a little bit of a problem. If you say print test scores, this basically doesn't work in a lot of languages. But in the world of Python, it works exactly as you think as it should, and it shows you everything. It doesn't do a really great job formatting. If you want this to appear one on a different line, you can't use this approach. But if you just want to see what's inside something, yeah, this is exactly it. Now, something that's very, oh, sorry, I don't want to get ahead of myself because otherwise I'll have nothing to talk about when I hit the next slide. All right, next one up. Python list can hold any type of items, including a mixture. Now, this is kind of bizarre because if you were to take a look at, say, Java or C++, um, and I said, hey, can you stick the word hello into your list of test scores? The answer is, of course, you can't. However, you know what? In PHP, JavaScript, and Python, yeah, you can get away with these things. Yeah, so what you've got now is you've got a bunch of test scores. One's a 78, a 67, a 90, an 87, and a hello. Now, is that convenient? And the really good answer to this is no, probably not. Every now and then you might want different types of things into the same list, but generally I'm going to tell you that when you're making lists of stuff, you want all the same types because different types really make things quite difficult. Like, for example, if I want you to calculate the average of the test scores, what do you do with this? And yeah, this ends up being a problem. Okay, so unfortunately, Python allows it, but that doesn't mean that it's particularly useful. Every now and then, I do have some uses where I end up with mixed values, but generally, I probably don't. And you can see here that somebody's gone through and they've stuck in a pass and a fail, and somebody's even stuck in a Boolean value called a true. And yeah, you can do that. Anyway, next thing up, so that is a collection. So it means a whole bunch of things. Okay, so that's fine. Let me clear this one up for a second. Okay, just we've got this. I said it's a collection of items. Okay, that's fine. Ooh, back to here. I also said that is an ordered collection of items. Okay, the word order simply means that there's a first, there's a last. Every item in the list has something that comes before it and something that comes after it. Unless, of course, it is the first or the last. Like, for example, I can always ask what comes before 90? Well, it's the 67. What comes after 90? 87. That's what it means for something to be ordered. And by the way, every time that I run the program, I always get the same order. Now, that's, of course, looking like it's going to be pretty obvious, but there are certain data structures that are not ordered. And as a result, you may see something a little bit strange when we hit them. Okay, but more importantly, there's the first element. The first element is 78, then there's a 67, then there's a 90, then there's an 87. And it is in that order. Okay. All right. Next thing up, it says that you can change, you can access, and you can iterate through the items. Okay. So what does that mean? Okay. Let me leave this one over here. Give me a second because my other screen has got some issues. Okay. Here. No, 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 no. Okay. Let me move this. Okay. Now I can see. Sorry. Things are moving around on me. Here we go. Now I can see what I'm looking for. Okay, perfect. All right, so here's the first thing. If you want to access a value, no problem. I just showed you how to do it. So you can go and you can pull out the first test score. Okay, notice it's not the lowest test score, it's just the first test score that's in the list. Here's something that's sort of interesting, however. We tried this with a string the other day, and we said, well, what happens if I go into the list and I try doing something like this, and then I print the test scores? When I tried to do this with a string, it turned out that that was a failure. But a list, on the other hand, can be modified. Okay, so lists can be modified. So the rest of everything else is still here, the 78, the 90, the 87. It just happens to be that I modified the very first element to be 99. And that's what I mean by it's modifiable. Okay, now let's get back over to here. Okay, so it's similar to accessing a character in a string. So first element 0, last element is -1. But here is the magic word. Lists are mutable. Okay, what it means to be mutable is it means that you can change an item without impacting anything else. Okay, now usually in my course, somebody has stuck in some comments in the slide saying strings are not are not mutable, and as a result, that's the reason why you can't change them. That's kind of not entirely true because it turns out integers are also immutable. But what I can do is I can show you one of the side effects that happens. Okay, so here's what I'm going to do. I would have like to have a bunch of test scores, and I'd like to write some functions because, yeah, functions weren't just something that we did, and now we put them away, and now we don't look at functions anymore because we're looking at lists. No, no, once you have functions, now you can write functions that work with lists. Like, for example, one thing that I might want is to display the scores. Now, this would be pretty simple because all I could do is I could just do a print scores and it displays things. Okay. I'm going to do things a little bit different, however. I am going to set up a loop. Okay. Well, first of all, I've got to cover one extra thing. How many scores do I have? Okay. Num scores. How many scores do I have? Now, your answer should be, well, it's 4. All right. But you know what? Here, okay, put it up here, scroll up here, and I'm going to ask the question, how many scores do I have? Well, I know it's 4 because I just saw myself put it down. But if you don't know, yeah, just like in the world of strings, you can say there are num scores. There we go. So yeah, you can use length to pick that up. And well, it doesn't actually do anything because I forgot to call the function. Okay, so what did I call it? I called it display scores. Display scores, test scores. Bang, you run it, there are 4 scores. And of course, if I go and I add an extra one, now there are 5 scores. Okay. All right, so there you go. There's the first thing that's kind of important. All right, what I would like to do, okay, let me bring this back up so I don't have to keep scrolling up and down. Okay, maybe this way will be faster. Okay. Okay. When I say display scores, it actually just displays how many there are. We'll get to that in a minute. And then what I do is I display the scores afterwards. And when I run it, yeah, I see that there are 5 scores. Then, of course, I see that here are the scores afterwards. All right, I'd like to try something. Scores at 0 is equal to 0. Okay, now we just talked about this like 1 hour ago. We said that parameters are like local variables, and therefore you can't change them. So our expectation will be that when I call display scores, I will see that there are 5 scores. This will basically be ignored because I don't have a global anywhere. And the result is going to be that when I print the test scores, I'll still see the 78 to 90, 67, the 90, the 87, and the 50, but instead it gets modified. All right, here's the deal. In the world, and sorry about this because I don't know if it's on the slides or not, but here's the thing. Okay, ints, floats, strings. What else have we seen? A bool. Okay, there might be some other types as well. Are immutable. Okay, you cannot change them. Oh, well, you can change the value, but basically what you're doing is you're creating a new variable. On the other hand, a list is mutable. And one of the things that happens with a mutable parameter is that you can modify what's inside. Okay, so passing in a list as a parameter will give you something very, very different than if you pass in, say, an int, a float, a bool, or a string. Those can't be modified, but mutable items can. Lists are mutable. We have a couple of extra things we're going to cover. It won't be today. It'll be tomorrow's one of the 3 hours. We will cover sets. We will cover tuples. We will cover dictionaries. Those are also mutable items. Okay, the basic types are immutable. The more complicated types are mutable. So we can change things. All right. I'm not actually interested in changing anything, but here's what I'm going to do. I would like to print out the test scores. Okay, so here we go. The test scores are, this is important in MySQL and database management. Let me think. Can I come up with an explanation for why that would be useful? Sort of, but not exactly. Now, I suppose that if we were to look at MySQL and database management just on its own, I guess the word mutable would be, can you modify one of the columns? If we're talking about MySQL, so I assume you are since you said it. I guess you could consider it kind of like being a read-only versus a read-write. Generally, most columns in a relational database can be modified. So it's sort of, but not quite. Okay, but here's something that is maybe related. If you wanted to modify a string in a database, you'd actually have to retrieve the entire string, modify the entire string, and put that entire new string back in. You won't be able to change a single individual character without taking it from the database first, changing it in memory, putting it back in. So it could be related to that. All right, but in any case, here we go. We're going to print off our scores. Okay, scores 0, print. Oh, here we go. Print scores 1, print scores 2. Wait a minute, this sounds kind of weird. Print scores 3. And I'm not going to print the scores here. I'm just going to run this. There you go. There are the 4 scores. Okay, nice. Oh, wait a minute. I didn't get 4 scores because there's actually 5. Oh, all I have to do is copy and paste one more time. Wait a minute. I've talked about this before. Copying and pasting, probably not a good idea. But notice that this is a pretty easy to understand pattern. It's 0, then 1, then 2, then 3. If there's another one, it'll be 4, then 5, then 6, and so on. Sounds to me like a loop. 4. What do we want to call this? POS. POS is my abbreviation for position. Okay, there's nothing special about this. POS is position in the list. Okay, for POS in range 5, print scores POS. Oh, hang on. Just print POS for a second. Okay, run this. Yeah, 0, 1, 2, 3, 4. Ooh, okay. But I'm not interested in the actual POS. I'm interested in the scores at the POS. And that is exactly what I'm looking for. Now I can start to do something a little bit more interesting, like I could say, maybe an F string, I could say score POS is scores POS. You see, when you on terminated string because I forgot to put a double quote. I knew that. See, score 0 is 78, score 1 is 67. Oh, yeah, okay. I am seeing everything, and that really is score 0, but is sometimes your users might be confused about starting from 0. I talked about this before, just add 1. So there are 5 scores. The first score is 78, second score is 67, score number 5 is 50. Hey, perfect. So this is one way to iterate through and pull values out. These are the types of things that you tend to do very, very frequently when you have a list. Yes, you will tend to use loops an awful lot when you're dealing with lists, and this is one particular approach. Again, those who have been through, say, okay, C++ and even JavaScript and Java, yeah, you're constantly writing things that look like this for I is equal to this, well, I is less than, let's see, scores dot length. Okay, I plus plus, and you're doing some kind of a C out and you're saying scores at I, this type of business here, or an equivalent in Java. Okay, so yeah, this is exactly the same thing that we just did. All right, so next one up, instead of having five, yeah, that would be a really, really good improvement. Thank you for showing that because right now, if I add an extra value, and now I've got an issue, it's not showing. And to make things even worse, if I pull it down, it's only got three. Well, now everything blows up because I'm trying to iterate through this. And you're absolutely 100% correct. And that is, this would make life considerably, considerably better. Okay, and this way, it's more convenient because I can just go and add whatever I want, and the values are updated automatically. In fact, to be honest, most people would probably replace this with the value num scores, okay, and they just actually wouldn't even put this, and here you go. Obviously, that's not going to work if you want to see there are so many scores, but quite often you get things like this. All right, perfect. So that's one way of going through and looking. So obviously you could just do a single print, but if you want something to be processed or shown in a different way, then you set up a loop. Now, I've got another thing which is really, really clever that can end up happening. Okay, remember we talked about for loops yesterday, and we talked about the fact that counted loops happen all the time. Yes, there is going to be a lot of times in your life where you will have an array of items and you want to go through all of the items in the array. Sorry, list is what I should be calling. Okay, shortcut. No, we don't quite get the same thing that I want. All right, but here we go. You can use a for loop like this, but what you don't get back is you don't get back POS. I'm just going to call this X for a second, and I will change this in a couple of seconds because I don't like the variable X, but I just want to show you what's inside there. All right, so we did this yesterday. We used CH in a string. This is X in a list. And you'll see what I get is I get exactly the scores. So what this is for score in scores, here you go, there's score. Those are the scores. Now you can do something with it. Unfortunately, if you want to know the number of the score, like score one, score two, score three, you need an extra variable. Okay. And that's kind of a bit of a downside. However, you generally don't need to know the position of something. You're really, really interested in actually just the values. Now, case in point, let's get back over here to my big, complicated examples. All right. What have we got here? Hey, take a look at this. Here's a function right here called transform entities. Here, I'll put it over here because I think the font's a little bit bigger to see. All right, so what does it do? Well, I guess it would be better if somebody had actually left like a comment in here saying what it was doing. Okay, well, guess what? This transforms the entities. I would have to look a little more closely at it to say exactly what it does. But basically, it's trying to change some patterns, some dates into something. It's changing trues and falses into ones and zeros. It's looking for date patterns and turning them into a format that's required. All right, but take a look at what happens. You see, this is passed in as a list and for item and data. Yeah, that's exactly what it is. What I've got is I've got a big long list of items and I've got to go through and I got to transform each one of them. Okay, so yeah, I use these things all the time. If you were to look at any other piece of code, you'll see that I'm constantly doing this for DS and data. Down here for objects in whatever that means. Okay, so and maybe one right here for data in CSV data. Yeah, I use these all of the time. I hardly ever use this for I in range. In fact, this entire application, I didn't even use the word range once. The for loops with the lists in Python is really, really quite common. Okay, let's get this back over to here. Okay, access engine changing. I think I've saved those. Oh, I've also talked about what happens if you go past the end, so I've already got that problem. I suppose what I better do is let's go back and put this in. Print score at position 100. Okay, that one blows up. Only access scores. There we go. This is what it looks like if you try to access something outside the range of a list. You'll get an index error, and it'll say that the list index is out of range. So try for a really big number, you got yourself a problem. That's what I was talking about here. The example I guess the example is okay because I asked for range in six. So it'd be 0, 1, 2, 3, 4, and it would also ask for position five, and it doesn't exist. Okay, how are we doing for time? 5 out of 12 and halfway through. Okay, I think we're pretty good. Okay, so if you want to iterate through a list to see all the values, okay, not to see them because you can easily print them. Most of the time, you want to go through and you want to do things with your lists. Like, for example, maybe you want to calculate. I've got an example coming up here in a couple of seconds. We'll go back, we'll talk about the hot days. Maybe you want to know how many days were hot inside a bunch of temperature readings. So right now, this is just a printing. There are two ways. You can either use a position in range. And again, POS, that could be any value at all. I would say the most expected value that people use when they do this is they use the letter I. I try to avoid it, at least when I'm teaching. But I'll be quite honest, if I'm doing it for real code, I probably use the letter I. But sometimes I'll use the word index or IDX as a shortcut. Okay, so yeah, sometimes it does happen. Okay, the two techniques are really interchangeably, but if you use what I'm going to call the correct code or the correct approach, you'll find that your code is easier. And most of the time, you'll probably find that the second version is much easier. The only time I ever use this approach is if I need to know where I am, or I need to look at two values inside a list and I need to compare the two list values to find out maybe is the first one bigger than the second one. That's the only time I ever use a for something in range. Okay, most of the time it's through here. All right, let's go back over to here because I've got a small program. Okay, remember yesterday we wrote up a little program to, or I think it was 2 days ago, we wrote up a program where we asked the user to enter a bunch of temperatures and then we decided which temperatures were hot, which ones were not. Okay, well, I'd like to modify the program just a little bit, and I'm going to take all of the temperature readings, so temperatures, and what I'm going to do, I'm going to stick it inside a list. Okay, so temperature readings. All right, so there's a 38 followed by a 49 followed by a 43. Oh, but you got to put commas between them. All right, the next day was a 40, 40, 41. Then we had a 40, and we'll assume that we had a 36 and a 44. All right, so I'm going to ask a very simple question. If I wanted to know how many temperatures I have, what would we do? Okay, well, we have a function called len, temperatures. Bang, there you go. There are 7 temperatures. Yes, there are. 1, 2, 3, 4, 5, 6, 7. That's exactly it. I showed you yesterday a cool little program called max, or it's a little built-in function. What this does is when you pass in a list, it actually will go through and it will find the biggest number. And that's really, really convenient. There's an equivalent one called min, which will tell you what the smallest number is. Yeah, this is the reason why lists are very, very useful because if you don't have a list, you have to set up loops and you have to look for the biggest number and keep replacing the biggest number. If you have everything in a list, it's actually really simple. You can just go and say, give me the max. You know, there's even something in here called sum. And if you ask for a sum, it'll actually go through and it will add up all of those values. Okay. And yeah, as long as you have actual values that can be added. For example, if I say the word hot right here, yeah, it doesn't work because guess what? You can't take 38 plus 39 plus 37, blah, 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 plus hot. Okay, because it actually doesn't know. They all need to be the same type and they all need to be numerical. All right, but in any case, we've got this sum. So it's very, very convenient. Yeah, we use this all the time. I'm not sure if I've got it in my exercise or my other program, but I do use it quite frequently. It might take a few minutes to find one. All right, but in any case, I'm not interested in this, but I'm interested in knowing how many hot days are there. Okay, hot days we were going to consider to be 40 or more. So that's 1, that's 2, that's 3, and that's 4. So there are 4 of them. So how do we find this? Well, unfortunately, that function doesn't exist. We could write it. Okay. In fact, I think we're actually going to write this one. I'm going to mark that down as the hot days. That's actually really cool. If that function existed, that would be really, really simple. And then what I could do is I could just figure out how many items are there using a length function. Unfortunately, we don't know how to do this type of thing. So let me do it a simple way first. You see, what I can do is I can go through each of the temperatures. So for temp and temperatures, again, this variable is whatever you want. If you want to call it that, you can do it. That wouldn't make any sense to me. A very, very lazy programmer would probably say for T in temperatures. Okay, I'm going to call it temp. Okay, just because I'm like teaching. If nobody was looking at my code, I would honestly use T. Okay, just because, well, programmers are lazy. All right, and you get to be kind of lazy as well after you're outside of my course. All right, for temp and temp, well, we already know what happens. If you print it, you're going to see everything, but I'm not interested in printing it. I'm only interested if the temperature is bigger than or equal to 40, then I'm kind of interested in it. And there you go. There are the numbers that are bigger than 40. But I'm not interested in printing them. I want the actual count. So what I could have is I could have something called hot day count, which is equal to 0 at the beginning. And instead of printing it, I'm just going to say hot day count to go up by, up by 1. There were hot day count days that were hot. There you go. So there are 4 days that were hot. And yeah, if I go and I change this to a 58, then now there's 5 days. Okay, perfect. So this is actually kind of a really cool little thing. Yeah, we just went through and we iterated through each of the values looking for something that we wanted, and we counted things. Okay, yeah, this is a very, very typical programming pattern. We do it all of the time. Okay, let me see. This one, okay, I've got another example of something completely different, but I want to do something a little bit strange yet. Now, remember what I said. It would be kind of cool if we had a function called hot days. All right, well, this should actually cover something. Let me just peek ahead 1 or 2 slides. Okay, it's about 3 slides ahead, but I don't mind doing this right now. All right, so what if I'm not interested in the actual count of the hot days, but I actually wanted the hot days? Like, I actually want to see the hot days. In other words, what I want to do is hot days should be equal to the following. It should be a 43, a 41, a 40, and a 44. That's what I want to see. But of course, I don't want to do this by hand. Okay. I want the computer program to tell me what were the hot day readings. Okay. Here's what I'm going to do. You see, hot days is actually a list because it's going to have more than one value. So what I'm going to do is I'm going to start with absolutely nothing. Oh, that is called an empty list. And for those who are in or who have been through JavaScript, you have access in PHP, no problem. If you have been in C++ or Java, you might look at this and you might say, whoa, you can do this. And the answer is yes. In Java, there's a really cool little thing, and somebody may look at this and go, hey, I remember that. I will reveal that in a few seconds. All right, here we go. Hot days. What's inside hot days? Nothing. Hot days dot append 44. Take a look what happens. I get exactly one value. Hot days append 50. The function, or sorry, officially it's called a method append, will go and it will add whatever you put here at the very end. If you have been through C++, you've probably never seen anything like this unless you wrote your own data structure. If you've been through Java, Java has something called an array list. Yes, you can use an array list for doing this type of thing. Lists in Python, you have it automatically. In the world of JavaScript, we're talking about hot days dot push 44. That's the name of the operation. Okay. All right. But in the world of Python, it is append. So instead of appending just a couple of fixed values, here's what I'm going to do for T in temperatures. Okay. So I'm being lazy. If T is bigger than or equal to 40, I don't want to print it. I don't want to count it. I want to go to hot days and I want to say append T. There you go. Those are the hot days. pretty swift actually. And when you start working with stuff like this in Python, as soon as you have to go back and you have to work in what I'm going to call an old language like Java or C++, you immediately groan and you go, oh, that's really quite unpleasant. PHP, yeah, we got something that's called an array push. Okay, so just so I've covered all of the bases. All right, but this is really, really, really cool. Here's the way how I would actually use it. Remember what I said, it would be really nice if I had a function called hot days and I could pass in the temperatures. And if I print HD, which is hot days, remember these are just names I'm making up, I'd like to see exactly the same thing. All right, well, let's write the function def hot days. This is my original data. Maybe I'll just call it data. Maybe I'll call it temp data, just so I've got something different. All right, so here's what I'm going to do. I'm just going to return nothing right now. Very, very boring. Don't worry, we'll fix it. If I do this right now, what gets returned is absolutely nothing, but I don't want this. I want to have a result which is equal to empty, and I'm going to return result. Okay, again, pretty boring. Now what I'm going to do is I'm going to say for t in temp data, and we just saw this a second ago, if t is bigger than or equal to 40, I'm going to say result.append t. And here we go. Now we get ourselves a function called hot days. So you want to know how many hot days you've got? No problem. It's the length of HD. See, what we've done is we've taken the complexity, we hit it up here, and now we've actually got the function, just like the sum, just like the min and the max. And yeah, you can write your own. Okay. And what I've done is I've written my own, which goes through and it pulls out exactly the hot days. All right. So that's actually really, really convenient. Okay, let's go back over here. Okay, so examples of iterating. Oh, okay. Take a look at the bottom one first. That's exactly what I did. Okay, this one right here. I didn't do this as an example, so sorry. I won't do it as a function. Okay, I'm going to ask you a question. Okay, the very first day, from the first day to the second day, did it get hotter? And the answer is yes. From day number 2 to day number 3, did it get hotter? And the answer is yes. From day number 3 to day number 4, did it get hotter? No, it cooled down. Excellent. So if you want to know whether or not a temperature is increasing or decreasing, you need to do things a little bit different. You actually can't use a loop that looks like that, temperatures, because you need to know what the current value is and what the next value is. Now, there's a couple of tricks that I can do, but generally what I would do is if I wanted to compare two things, I would use for POS in length temperatures, print POS. Now, what that's going to do, int, line number 3, and sorry, range length temperatures. Sorry, let's put it back to the way it did before. All right, so you see what I'm doing? I'm going through all of these values. Now, I'm going to say the current temperature. The current temperature is the temperatures at POS. The next, current tomorrow. No, I don't want to call it tomorrow. Next reading, reading. The current reading and the next reading. How do you pick up the next reading? Well, the way how you pick up the next reading is actually pretty simple. You say POS plus 1. So watch this, reading and next reading. You see what I'm going to get, sorry, temperatures. You see what I get is I get the 30, the 38, the 39, the 39 to 43, the 43, the 41. What I'm doing is I'm picking up each of the pairs. Oh, but I've got a blow up here at the end. Why? Well, because I went all the way to the end, I tried to compare this to the next one and it didn't exist. So what I have to do is I have to subtract 1. There you go. There's all the values. You see, now based on this, I can ask questions. If reading is bigger than next reading, I can say what happened? Well, it must mean that the temp decreased, and otherwise the temp increased. Bang, there you go. So you can see here from 38 to 39, it went up. 39 to 43 went up. From 43 to 41, it went down. And it went down, and it went down, then it went up again. So when you're trying to compare one value to the next inside a list, then you have no choice but to use this for in range length. Okay, so that's what I was saying earlier. There are times that you need to use the format that I was using for T and temperature. That's the more common one. But if you're trying to compare things, then you need one of these positions so that you can access the before and the after. Maybe you're even trying to do some weird stuff like averaging. Okay, how are we doing? 42. Hey, we're not doing too bad. Let's see what we got next. So that's my example right here. I was just counting up the number of increasing rather than printing. Okay, so contains an index. Okay. Ooh, okay, there's a couple of really, really useful functions in here. Okay, I'm going to ask, is the number 40 in temperatures? And the answer is, yes, it is. It's right there. Okay, well, how can I find it? Okay, well, you know what? There's one thing that I can do for T in temperature. Okay, and what I'm going to do is I'm going to ask if T is exactly equal to, T is equal to 50, or sorry, 40. Printf, I'll just say the 40 was found. Was found? Bang, there, temperatures. There you go. So the 40 was found. If I was trying to find, say, 95, well, nothing gets displayed because it's not there. Yeah, going through looking for things, it is something that we do quite often. It's interesting that somebody's talked about MySQL because in the world of MySQL and database stuff, we're always looking for things. So do we have some ability to find things? And the answer is, yeah, actually we do. Watch this. If 40 in temperatures, print yes. And just so I've got something, I'm going to say the no on the other side. No with an E. Okay, this way. So yes, 40 is in the temperatures. On the other hand, is 45 in the list of temperatures? And the answer is no, it isn't. But now here's an interesting thing. Okay, 41. Is it in the list? And the answer is yes, it is. And I'm going to modify my list a little bit. Is 41 in the temperature? And the answer is yes, it is. You could really care less how many there are. The question isn't how many there are. The question is there one in there in the first place? And that's it. Now, there's a couple of extra functions that can also be very, very useful. Okay, one of the method functions that I have, I'm just going to call it POS. You can say temperatures and you can say index, and I could put 43. I'm going to print POS, and I'm going to ask a question before I run it. Is the number 43 in the list of temperatures? And the answer is yes, it is. Where is it? Well, it's right there. What's the position? Well, remember everything starts from 0, so this is 0, 1, 2. That's in position number 2. That's exactly what index will tell you. If I ask for 44, you'll end up getting number 6. Well, here, 0, 1, 2, 3, 4, 5, 6. Yeah, there it is in position number 6. Very, very useful if you're looking for something. What if I ask for 41 because it's here and it's here? Well, what it ends up giving you, it gives you the first one that it finds, 0, 1, 2, 3. What about this one? It could care less. When you ask for an index, you get the index of the very first value. And of course, well, the real question becomes then is if I ask for 50, what does it tell me? Because 50 isn't there, well, it turns out that you get a crash. Okay, so unfortunately, if you're going to use index, you have to check first to make sure that it's actually there before you go and actually try to get the position of it. Okay, what else have I got? Okay, yeah, okay, that's fine. I can just show the example that I've done without me having to type it. All right, so that's exactly the same thing. The temperature was fine. If you want to make sure that you don't have any crashes, then what you have to do is you have to use an if statement with an in first to find out if it's there. If it is there, then you can call index to actually pull it out. Okay, pretty straightforward. All right, adding something. Okay, no problem. Temperatures dot append 99. Okay, I've already shown you this one, how to add something. That's nothing really bizarre. The one thing to watch out for, however, I get a lot of students who try to do things like this. Okay, can you append a list at the end of the list? And the answer is yes, you can. And what you end up with is you end up with a list inside the list. Watch out. That's the next lecture that we'll cover in like 14 minutes from now. All right, but there are two extra functions I think that I would like to cover. And the first one is the option called remove. And if you look at this and you go, yeah, I think I know what this is going to do. Okay, here you go. If I ask to remove 39, yeah, it removes 39. Okay, it does exactly what you want. If you try to remove the value 50, it's just like what happens with the index. It gives a crash. So you have to make sure it's there first. The only other one that's kind of bizarre is if I ask to remove 41, does that get rid of both of them? And the answer is no, it doesn't. It only gets rid of one. It removes the first one that it finds. Okay. All right. But there's another operation for removing things, which is very, very important. It's called del. Now, there's actually a couple of extras, isn't there? Pop, 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 pop. Sorry, let me do it this way. Temperatures dot pop. Because I don't think I've included it in the slides, because I don't think it was in the original document either. All right, take a look at this. If I say pop 38, or let's just say the word pop, I want to show you what things look like. Let me print temperatures first, then I will call pop and I will do this. Take a look what happens. It removed 41. Pop is the opposite of a push. Okay, it has to do with stacks. You cover that in some other course. But what it does, it gets rid of the very last thing. So it's like a way to undo and append. But this also takes a parameter. And take a look what happens if I ask to pop 0. Okay, take a look at the before and take a look at the after. You see what I've done? It removed the very first element. If I try to pop number 4, you see what I'm going to get is 0, 1, 2, 3 will be the same, but then 4, what used to be a 40, is now removed. So this is removing something at a particular location, okay, as opposed to removing the value. If you try to remove 38, yeah, that blows up because basically it says, please remove the element at position 38, but of course it doesn't exist. Just as a warning, that does exactly the same thing. It's the same thing as the line that I just put right here and puts in comments. So you can either use pop or you can use del, entirely up to you. Usually if I'm trying to remove something, which I'll be honest, I almost never do, I usually end up using pop, but you can use whatever you want. Okay, no comments there. Okay, good. We're really close. We're like 1 minute, and I think we might just have one more slide. Okay, good, 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 good. Okay, programming pattern, building a list. Oh, excellent. You know what? I just did this already with an append. All right, since I'm a little short on time, I won't bother typing it, but I'll at least look at the code that I've got here. This is a very common pattern. You start off with a result is equal to 0 or something equal to, sorry, an empty list, and you set a loop and you go through looking for something, you input values or you filter values. I showed you filtering, and you use the append to build up one thing at a time. So you can see what the programmers typed here. They started off with temperatures equal to 0. They put themselves into a for loop for 5 times. I know I is not a very good one, but that's fine. So this loop happens 5 times. What does it do? It asks the user to enter the temperature 5 times. What does it do each time? It takes the value that was entered and puts it into the list. So at the end, you'll have a list of all the temperatures. Okay, there you go. And then we went through and we found out which days were the hottest, and we built up a list. Okay, cool. I kind of did this. I did it as a function. Okay, here you go. Here's a slightly simpler version. No, in fact, I've pretty much done exactly the same thing here. Okay, perfect. So yeah, we were like a few steps ahead. All right, excellent. So 550. All right, not bad. So that means now we get to take a break once again for another 10 minutes. So as usual, go off and enjoy a break for a little bit. And of course, I do want you to try these types of things. Okay, so at the end, I will show you which ones or which exercises are probably useful given today's stuff. And I have a little tiny piece of information about the final exam as well. I don't have everything. I don't have the time. Sorry. I don't think I'm going to get the time, but at least I have the format of what the exam was last time. So I'll share that with you before we end up going. All right, let me stop and get a 10-minute YouTube countdown timer. Here we go, 10-minute timer. Ooh, here we go. And over here. Ooh, no, it went somewhere. Where did it go? There we go. All right, so once it reaches zero, we'll start up again. Okay, welcome back. You've lasted this long. Uh, we've only got another 50-minute stint. Okay, and then one more time tomorrow. Okay, so hopefully I have enough stamina to go through. I don't think we'll finish super early this time like I did yesterday, but hey, let's find out. If I can manage 10 minutes early, that'll be excellent. I guess it depends on how much detail we want to go into nested lists. Okay, nested lists. I kind of debated about whether or not this is really important, but in terms of programming, I'll be quite honest, we don't really use them a whole lot. We use them a lot in our intro programming course, mostly because I think somebody said, hey, let's include this. But I'll be quite honest, in actual real programming, they're kind of minimal. However, I'm including them here only because I've dealt with the data science course before, and quite often you end up using nested lists, or at least something that looks very much like a nested list. So as a result, it's probably worthwhile including it here. All right, so let's get started on this. And again, as usual, we'll do some examples as we go. All right, so my introduction is, once I get the page switched over, here you go. Let's suppose that you are trying to represent this chessboard. Okay, now the thing is that you have 64 squares because it's an 8 by 8 grid. This was actually an exercise, and if you look inside the exercise I gave you, it's there. I don't really like the exercise. I've gotten rid of it already, but you still have it. But the issue is that there are 64. There are 64 things. So you wouldn't want to have 64 individual variables. Instead, you'd have, say, a list with 64 elements. Now, that's one way, is to have it as a list of 64 elements, but really this whole thing right here has been structured in a very different way. This has been structured in the format of a table. I believe that you have seen me pull up right here, Excel. So let me pop open one for a second. Here we go. Here's Excel. Don't worry, it's not a course about Excel. Excel is really, really useful because it's a table format. Now, let's suppose, for example, I had a whole bunch of test scores. All right, so I'll just pick the names out of here. I'm going to give you guys some scores, but I won't make. Don't worry, these are not your scores. I'll have to give everybody almost a full mark just so nobody's freaked out by things. Let's see, shade and yeah, sorry if I misspelled your name. Now, imagine if you guys were in a class with me. Quite often, what you'd end up with is you might end up with, like, say, test one. You might end up with test two. You might end up with test three. You might end up with the final exam. All right, here you go. Now, I'm just going to make up some numbers. Sorry, I'm not going to suggest or that anybody's going to do badly. I just need some numbers in here, okay? All right, and I don't think so much about these. So here, I'll try to keep them pretty high so that always makes everybody feel quite good. So here's, sorry, get a slightly lower one. Nobody's getting a perfect mark. That's not true. I don't do this. Let's see, 100, 100, 100, 100, 100, 100. Everybody likes that, but of course the issue is this probably means the test was too easy, et cetera, et cetera. You know what? Let's just trash this one. But here you go. Here's a bunch of things. Now, why would I keep it in a spreadsheet? Well, pretty simple, because I want to be able to calculate things like averages so that I can figure out, hey, what's the final scores that I need to give you guys? Okay. So, I mean, this is the reason why we do these types of things. But we put them inside tables because it's easy for us to understand. A table has a row, has a bunch of rows, and tables have a whole bunch of columns. If we look at, say, a list that I just covered, well, there's no rows and columns. There's only just a single row, I guess. And yeah, there's kind of something to that effect. All right, so if I had to store a whole bunch of data like this, and sorry, I'm just going to pick one extra number in here because I think it'll be a bit easier. Maybe this one was a harder course. Again, these are not your scores. This is just me making up a bunch of data. All right, this thing right here, as I say, this is a table. Let me put some borders around it, and I'll trash the grid just to make it a little bit easier. There you go. There is a table. Okay, done and done. Now, if you take a look at, say, the chessboard that I've got over here in the corner, yeah, you know what? There's a lot in common between these two. It's a table of information. Here, it's test scores. Over here, they're chess pieces. So this is a king, this is a queen. So yeah, that should be all right. We've got ourselves the bishops, we got the rooks, we got the knights, and we got all the pawns up here. So you could actually store different values in here. But to begin with, what I'm going to do is I want to take all of these numbers right here, maybe including the scores, maybe not. Maybe what I should do is I should call it student one, student two, student three. Okay, but you know what? I'm just going to leave the names again. Don't worry, I'm not suggesting what your scores are going to be. I just picked up your names, made some random stuff. All right. If I need to store this information in Python, can I do it? And the answer is absolutely, I can do it. There's a few different ways how I could do it. Okay, so put this out of the way, and here's the first way that I could do it. Okay, scores. Okay, scores. Now, for my scores, I need to, oh, this is going to be tricky. I'm going to put my scores down here so I can see them at the same time. You go away. Okay, that was too much stuff going away. There we go. Now I can see the scores, okay, at the same time. And I'll make it a little bit narrower. There we go. So the scores. So what do I have? Okay, well, I have, oh, sorry, not enter. I have a 90, I have a 97, I have a 100 and a 70. But I also have a 60, I have an 89, I have a 100, and I have a 70. I have a 70. I should have less students, a 78, a 180, a 90, an 80, a 100, and an 80, a 100, and a 96, and a 100, and a 90. There you go. Print. Scores. All right, is that everybody's scores? Not quite, because I see I made a mistake in here with a 78. There we go. I now have everybody's scores. Very, very poorly organized. Like, for example, okay, boop, boop, and I'll toss it back in here and I'll ask, whose score is this for what test? Now, if it happened to be you, yeah, you'll remember what score I gave you. But the problem is, if it's anybody else's and you didn't have an 80, you're not going to have any idea. So you see, this is very, very disorganized. Okay. I can fix up the organization a little tiny bit. Remember, there are 4 scores for every student. So what I'm going to do is I'm just going to go and I'm going to press enter after each one. There you go. You see, this makes life a little bit easier. You see, what I can sort of maybe conclude from this is that there are 4 test scores for each student, and there are 1, 2, 3, 4, 5 students. Okay, the problem is that I don't know who's who, and if I run the program, the output is still completely messed up. I can't tell what's going on. Okay, so but it is a little bit easier to see here, and it looks an awful lot more like that grid that I wrote in the first place. Okay, so life is much, much better this way, but it's only for us, it's not for the program. Okay, so here's what I'm going to do. Rather than just having a whole bunch of these things, oh, and by the way, yes, I can just press enter whenever I want. You can do this with an array, or sorry, a list. I'm going to help organize things a little bit. You saw already a little while ago that I can actually stick lists inside lists. So here's what I'm going to do. I'm going to put a beginning of a list, an end of a list, an end of a list, an end of a list. You see, now if I run this program, take a look. These are the scores for the first student. I don't know who it is, but it's the first student. This is the second student. This is the third student. This is the fourth student and the fifth student. I can tell on test number 1, the fifth student got a 100. See, by putting things into a structure like this, now I can start to see what's going on. And that's very, very, very useful. Okay, and this is all programming is about. It's how do you structure things to make things more useful, make things easier. And by grouping things together and using lists of lists, I can get things that look a lot better. And again, as I said, the really cool thing here is that if I just do a little tiny bit of formatting, you see, now it really is starting to look an awful lot like that table that I had. I think it's right here. Let me hide this, turn hiding on. Okay, here we go. It's starting to look an awful lot like this table. Okay, it's much, much easier to read. The only thing that's really missing is the name of the student. Could we add it? And the answer is, yeah, I can actually do it, but I don't want to yet. If I have time, I will add it because it adds a whole pile of complexity as well. Okay, so now let's go a little bit further. Great. So now, how do we make use of this? I mean, this is great. At least I can kind of see things, um, but this is not very convenient to look at. Well, first thing I'm going to demonstrate is if I start to use subscripts, remember what this does. This pulls out the very first thing because what I have here for scores, I suppose the question I might ask is how many scores do I have? Somebody's going to say 1, 2, 3, 4 by 5. There are 20 scores. All right, but if I ask for the length of scores, you're not going to see the number 20. You're going to see the number 5. Why? Well, because in this list called scores, there are 1, 2, 3, 4, 5 items. Yeah, they're lists with a bunch of other things inside them, but there are exactly 5 items. And that's why it says, in other words, this is the number of students. Okay. And it happens to work because, well, we're using scores. Obviously, if there was something different, a chessboard, it's going to be it's going to have a different meaning. It would probably mean the number of rows. All right, but now if we go back and I ask you to print scores at 0, what are we going to see? Well, we're going to see the 90, the 97, the 170, because that is the thing which is in the very first position. If I ask for scores at 4, I'm going to see this one right here because that's the stuff that's in position number 4. All right, so good. So this is pulling up the individual students and all of the records about them. But I can go one step further, and this is the thing that I know you guys are going to see in DSAI when you start to work with all of this pandas and numpy stuff, because you'll be constantly doing this type of thing. If I wanted the very first number right here, 90, what I would have to do is I'd have to say, okay, give me the row number, 0, and then give me, say, the column number, which is, of course, position 0, because the first one right here gives me the row and the second one gives me the column. So there's a 90. If I was interested in the first test of the last student, it would be student number 4, test number 0. And that's how I could pull out the 100. If I was interested in, say, this number right here, 78, this is in row number 0, 1, 2 and it's column number 1. There you go. There's 78. So in other words, the way how to think about this is, yeah, it's the row number followed by the column number. That's what this means. Okay, so what I've got now is a bunch of table data, tabular data, and this is how you pull out information for a row and for a column. And as I said, the one thing that's sort of unfortunate is that the name of the student is not here, and the name of the assessment is also not here, but I promise to fix the name of the assessment next time, okay, because that will be something called a dictionary. That's very, very important here. All right, so now let me get back over to see what I'm supposed to be doing so that I don't end up doing the wrong things. But here we go. So a nested list. A nested list is a list where each element is in itself another list. So it's often used to represent rows and columns. Okay, there's a couple of extra words of two-dimensional data, each sublist. Okay, so the smaller lists inside is often called a sublist. They can have different amounts, but it's like what I said before, consistent amounts are much easier to deal with. Here, case in point. Okay, there are definitely 5 students. Okay, this is student 0, this is student 1, this is student 2, this is student 3, this is student 4. This is definitely student number 4. Student number 4 has 3 test scores, but the thing is, I don't know which test scores these are. It might be that this is test 1, test 2, test 3. Was there a test 4 in here? Yeah, there's also test 4. But maybe it's test 2, test 3, test 4, or maybe it's test 1, test 3, test 4. I don't know which one is missing. We're going to have to solve that problem later. But this is completely valid, but the problem is it's hard to understand. Now, the way how we might actually want to use this thing is to do something like this. Okay, so I showed you how to hard code some print statements, but let me do this. I'm just going to use X and I will replace the word X with something else. For X in scores, print X. Okay, what do I see? Well, those are test scores for a student. So likely what I would do is I might just call this student, print student, and those are student scores. What if I wanted to print out the individual items? Okay, well, here's what I would have to do is I would have to go through and I'd have to iterate through each of these because remember, these things are now a list. Okay, and how to print out the individual things? Well, what I could do is I could say for X in student, print X instead of printing student. Here you go. That's all of the values being completely dumped out, basically one on each line. Okay, now, why would we want to do something like this? Okay, the reason why we want to do stuff like this is we want to be able to say, maybe calculate an average. Now, how do you calculate an average? Okay, well, here, print student. Let me not print this one. Bang, there you go. That's an individual student. How do you calculate the average of something? The good news about how to calculate an average is remember that there's something called sum, which will add up all the values, and that is the number of things. This, of course, would be, I'm going to call it AVG because I'm lazy, but that would be average. And here's what I'm going to do is I'm going to print the AVG. Take a look at this. You see the average of these numbers is 89.25. The average of this is 79. The average of this is 82. The average of this one is 87.5. And the average of three is 95.333. All right, so very, very useful. And if you're trying to calculate things, yeah, this is exactly what you want. Okay, let's get back over here to the slide so I keep on track. All right, so is it possible to have different things? And the answer is yes. It's called a ragged nested list as opposed to a rectangular one. Rectangular ones are much easier to work with because you know that everybody's got the same thing. I would actually probably spend like an hour and a half on dealing with nested lists in a regular semester. It just happens to be that we're down to a smaller subset of time here. But that's okay because although I said it's kind of important, chances are you'll probably be using arrays of objects more than you'll be using arrays of arrays, or sorry, lists of lists. All right, so here we go. So we got three different formats. It's called a rectangular nested list where everything's got the same number of items. This has fewer items, but it could have any number at all. This is called a ragged list. The first list has three items. The second list has two. The third list has one. You can have any number at all. And there's another format here called the flat list, which is basically everything just in a single list altogether. Okay, so that's what a nested list is. How do you access and modify an element? No problem. All you need is you need two indices. Indices, that's spelled incorrectly. It's INDICES. Okay, it's amazing what I can spot when I'm actually working through this. The first index selects the inner list. The second index tells you which element within the inner list. All right, so when we were talking about 1 and 2, we're talking about row number 1, column number 2. So this would end up being the value 60 if I was to print it. And yes, you can also modify what's inside, no problem. So 2 comma 1 would change. Let's see, 2. So this is row number 2, 0, 1, 2, and column number 1. It would change the 80 to 99. And yeah, you could print it out to see it. Okay, now here's an interesting thing. Although it isn't really critical, I thought it was important because most of the textbooks, when they talk about two-dimensional arrays, which is what we've got here, they always bump into the concept of something called row major order versus column major order. All right, let me get over to here and let me type in the values again. Okay, I need this one to be here, this one to be here, and I'm going to write the scores. All right. So before, remember what I did. I made a list and I wrote 90, 97, sorry, comma, 97, 100, 100, 70, and then I put the next list and I wrote 60, 89, 100, 70. All right, what am I doing? Well, I'm basically going through each of the rows one at a time. That's what is called row major. All right, now I'm going to do something a little bit different. Watch this. 90, 60, 70, 90, 97, I'm sorry, 97, 89, 78, 80, 96. All right, 100, 100, 100, 100, 100, and 70, 70, 80, 80, 90. There you go. That is exactly the same information that I just had, but instead of doing it a row at a time, I stored it a column at a time. Okay, this is called column order format. Is one better than the other? Well, I would certainly say that row major format is a lot easier to understand because, I mean, these things really do look like rows. However, you have to watch out because there are certain programming languages that actually store things in column order format. As I say, it is not really all that critical for this course. It was just kind of like one extra thing. I needed an extra slide in my usual course, so I thought, you know what? I'm just going to end up including it here. Okay, but in any case, that's the difference between row major format, or sorry, row major versus column major order, where the first index might represent the column rather than this. Could I elaborate further on it? I could, and do I want to? No. Do you want to learn more? I'm going to tell you the answer is not really. Um, it was really just a matter of when you list these out, do you list it this way in each initial thing, or do you go a column at a time? Okay, and that's really the only difference. So here, what I will do is I can pop this one open, and I'm going to call this as column major order. And the alternative scores might be like this: 90, 97, 100, 70, next 60, 89, 100, 70, and I'm just going to say etc. All right, and this one right here, this is row major order. Okay, so there you go. So it's basically, are you listing out the individual items by row, or are you listing them out by columns? They can both be used depending on how you're treating the data, but obviously you have to treat the data the same way. Most people would use this way and they would never do this. Okay. But just letting you know that you might get stuck sometime with some data that somebody has stored in a slightly different format. Not my courses, because I would almost always do it exactly this way. Okay. That's about as much as I'm going to elaborate, because don't worry, there's not going to be a question anywhere. I'm really just covering it because, just kind of in case. Okay, but don't worry, it's not going to be in case of this course. It's just in case you bump into this sometime. Okay, so I don't want to elaborate too much more. All right, iterating values in a nested list. Ooh, we've actually kind of done this already. You see, to be able to extract each of the individual items, what I have to do is I actually have to use two loops. I have to use one for each of the rows, assuming row major order, which we always will, and then we need another loop inside that loop to handle each of the items within the row. So the outer loop handles the row, the inner loop handles the elements. Where did my stuff go? Um, okay, so for X in scores. Okay, if I was to print X right now, what I would end up seeing is the individual rows. So here, I'm actually going to call this row. Row, bang. It's exactly the same thing. That is a row. But of course, if I wanted to see the individual values, I could say for call in row, and I could say print call. And what this will do is this would iterate through each of them. So for every row, it'll do this one, and it'll list out the 90, 97, 170 right here. And then it would do the next one, which is right here, and this group right here, those four items. Okay, so there you go. That's how to iterate through. So yeah, luckily we'd already done this. That's one way of iterating through. I believe that I've got another way. So you can use the for loops if you just need to know the values. So why would we do this? Well, maybe I have to add up all these scores. I don't know why I would need to add up all the scores, but maybe I've got a total and I could say the total is equal to the total plus the column. And then I could print out the total, and this would give me a total of everything. So all of these numbers added together is 676. You can try that in a calculator to make sure. Okay, sometimes you need to do that. Do you do it very often? No, probably not. But what I might do is I might be looking for how many A's do I have? Okay, that's a reasonable thing. Okay, so let's call it the A count. All right, so I start off with nothing. What I would need to do, I don't like call really anymore. I like to call that the grade. Okay, I could still call it that. But I could say if the grade is bigger than or equal to 90, my A count would go up by 1. And then I could print out an A count. Bang, there you go. So there are four A's out of this. And yeah, I mean, I don't know who they are, but yes, there's one, there's two, there's three, and there's four. And that's exactly the four. Okay, so quite often, if you're dealing with these nested lists where you have a list inside another list, it is very, very often that you need a for loop inside another for loop. Okay, so just keep this in mind. All right, next one up over to here. All right, so that's an element-based thing. So that's going through and printing everything. Index-based loops, okay, they're a little bit different. I'm not even sure if I want to bother writing this one because I'll be honest, I don't use it that often. Okay, but see what the person has done here is they've said they've got this two-dimensional list, this nested list, and they've set up for I in range length of table. So what they're doing is they're going through each of the rows, they're going through each of the columns, but the I and J are not the values, but they're indexes. It's 0, 0, 0, 1, 0, 2. In fact, you know what? I think what we'll do is we'll go ahead and we'll grab this. So if I can grab the code, no, not this code right here. Okay, I think I can copy and paste this one. Bang, here you go. So you see, when you run something like this, you see I've got this I, which goes through 0, 1, and 2, and then within each one of those, I go through the value of j. So I have this combination, and what I'm doing is, oh, sorry, because it's zoomed in, we can't quite see. Here we go. I'm going and I'm picking up the position I and j. All right. So reasonable if you need to iterate through. So what else have I got here? I got a 2D list dimension. Okay, this one can be a little bit tricky. Okay, and then what we're going to do is we're going to finish off with kind of a, what else do I have? Okay, I've only got a couple more slides, and then I will provide a little bit of truth to this and what you would actually do with things. All right, remember that the length of data tells you number of rows. It tells you how many inner lists you've got. So if I ask for the length of grid, it's going to say 3. The same way that I showed you when we have a bunch of students, the length of the scores are really the students. If you wanted to know how many scores each student has, you'd have to call length on each one. Unfortunately, unless you have a rectangular array, it doesn't really work. Okay, but this one right here, the length of grid 0, well, that's this one right here. It'll be 4. So this has 3 rows and it has 4 columns. It's the way how we pull things out. I'm going to skip this one. I'll let you guys read through this on your own, and I'm going to let you guys read through your own. I'm going to give you a hint, however. This is a very popular question. We've made students do this on lab exams many, many times in INFS 1201. So probably worthwhile. We actually now give it as an example. So I would just say go off and give this a try and see what the data looks like after you've done it. You'll have to make up a two-dimensional list and then see what you get back when you call this function flatten list. Here's a hint. It's about turning a 2D list into a single flat list. Okay, and this is actually, I believe, the final slide. So what I want to do, however, is I want to pull up this information one extra time. Okay, here we go. Test scores. Okay, let me put this data back in. 90, 97, 170, 60, 89, 170. And I'm going to go just one more row, and the rest of you, sorry, you'll be left out. Okay, here you go. Test scores, done. Okay, all right. Print, test scores, pretty boring right now, just prints off the test scores. All right, based on the information you see here, not the information back here, what's the name of the second student? Well, I can't tell. I can tell if I show you, but you can't tell here. All right, what could we do to make this a little bit better? Okay, here's what I could do. You see, I can do things like this because remember, in the world of Python, I can put in mixed types. All right, so you see now when we run this, I'm starting to see some more information. I can tell Fatma's scores. I can tell Dana's scores. I can tell Abdullah's scores because I've included the name of the student as part of the list of scores. Convenient. Okay, yes, it really does add some convenience. Unfortunately, it really causes a lot of trouble. Okay, because watch this. Let's calculate Abdullah's average. Okay, now obviously we could do this by hand. You take the 90, the 97, the 100, and the 70, and you divide by 4. Unfortunately, here's the problem. Okay, so let's have a variable called, okay, we'll just call it student one. Stu1, student one. That's the name of my variable. Maybe not a great student. Uh, First, okay, first student. Test scores 0. Print first. I want you to take a look and see what you got inside here. That is the information from test score 0. It's the name of the student followed by their 4, hopefully it is 4, test scores. Okay, perfect. If I wanted to calculate the average, how do you calculate the average? Well, I showed you a really cool little trick before. You take the sum of the first and you divide it by the length of the first, and all you do is you print out the average is equal to an average, and you run it. Unfortunately, when you run it, everything blows up because you cannot take those 5 values and add them together. The problem is right here, you can't add this to a bunch of integers. The sum only works if you have just values. All right, so here's what I could do. It's gross. It's gross. I really don't like it. I've got 2 or 3 really cool tricks, but I'm going to show you this one because I've got that weird name at the, sorry, it's not that you got a weird name. It's just your problem is your name is weird, not the name itself, but the fact that everything else is an integer, but then I got somebody's name. And I have to somehow or another skip the name. Okay, this is really the big issue. So here's what I'm going to do. For me to skip the name, I've got 2 approaches. Here's my first approach. I could have a for loop in range. No, how many? Oh, well, hang on. 1, 2, 3, 4, 5. Okay, and here's what I'm going to do. Yeah, I'm going to go through these, but I'm not interested in the first item, so I'm going to start at 1. Okay, but I'm going to go up for this. I'm not going to go for this. I want to go for the length of first. What have I got? Oh, perfect. It's exactly what I'm looking for. And now what I'm going to do is I'm going to have a total. I'm going to set it equal to 0. And I'm just going to say that the total is equal to the total plus the first at POS. And then I'm going to print total. And of course, what I get is I get a 357. And what this is, these are these numbers right here added together. So if I want to calculate the average, stop it. That's this editor trying to be helpful. And I didn't want that much help. Okay, I'll get it in a second. The average would be equal to the total divided by, well, I guess the length of the first. Okay, is that actually it? So print the average. Bang. 71.4 seems reasonable. Bill is not going to be very happy, however, with this calculation because this is absolutely not his average. You see, the average should be a 90 plus a 97 plus a 100 plus a 70, and this should be divided by 4. The average should have been 89.25, not a 71.4. What happened? Well, I have a theory that I took 90 plus 97 plus 100 plus 70, and I have a feeling that the person divided by 5. Yeah, and that's exactly it. Why? Well, because there were 5 things inside the list, and that's why. So unfortunately, it would be the length of this minus 1. Sorry, there we go. Close it, there you go. And that's finally it. Okay, so there you go. So we can deal with it by basically using a range and skipping over the first position. I've got something much, much better, however. Remember that. Okay, if I print first, what do we see? Well, I see everything, including the student's name. Okay, let's see if you remember what that does. That is list slicing. That is everything starting from position 1 to the end. That is everything except for the student's name. Oh, perfect. So that's the actual test scores. So here's what we're going to do. We're going to say first student, and here's what we're going to do. The name of the student is first student at position 0, and the scores is first student 1 colon. Okay, so now take a look at this. I've got the person's name and I got their scores. Bang, there you go. Abdullah, followed by exactly the things that I need. Now, the cool thing is that once I have what I need, now I can do my average calculation by taking the sum of the scores because scores doesn't contain that person and just divide by the length of the scores. I've got no weird things that I'm trying to ignore, but that's exactly the calculation that I require. This is taking a bunch of, I'm going to describe it as poorly formatted data and breaking it into two pieces. The first piece, which is the name, the second piece, which is the list of scores. When you guys do your data science course, you will learn about doing things called data cleaning, and this is data cleaning. Sometimes it requires that you get rid of things like spaces at the end. And by doing this, well, there's an operation called strip. I think I showed that the other day. And you might go through and you might collapse these into a single number, or maybe you'll elaborate them, or maybe you'll fill up values that are missing or set them equal to 0. It really all kind of depends. And maybe you just have to go through and calculate an average. These are sometimes the types of things that you have to do in order to prepare your data for analysis. Okay. Now, the one thing that is kind of a problem here is I still don't know, for example, if I remove that score right there, I don't know if Dana ended up skipping test 1, test 2, test 3, or test 4. I know that one of the tests was skipped. I don't know which one. That is a problem that I can solve, but not today. However, here is often what people will end up doing if they have a bunch of data in this format. Again, we can do it. I don't want to write the programs for it because it's really, really complicated. Test 1, test 2, test 3, and test 4. And what I need to do is I need to make sure that there is at least something in here. Maybe it's a 0, maybe it's the word none. And based on this, I can tell that this student has not done test number 4. Okay. In other words, I need to fill it out so that everything looks the same. But now what I've done is I've said that the student has missed test 1. This is what I often end up doing, and I put labels here at the top just so that I know exactly what test it happens to be. This is very, very tricky data to work with, but what's going to happen in your data science course is you'll be able to take this and they will have some libraries that will immediately turn this into something that's much easier to work with. And yeah, it is actually going to be much, much easier than what we're dealing with right here. I don't have enough material yet to explain how to turn this into something that's easier to deal with. I need something called a dictionary. Once we have a dictionary, which will of course be next class or maybe the middle class tomorrow, then we will have things in really, really good shape. Okay, so here you go. Now, nested lists. Okay, lists of lists. Are they useful? Are they used? Okay, you know what? As usual, I like to have sort of honest descriptions about what's going on. Okay, so first of all, let's pop over and let's take a look and see, did I use them? Because if I use them, then obviously it's kind of important. If I hardly use them, maybe it's not so important. So how can you tell when you have a nested list? You will see things like this. You'll see two brackets, one after another. Okay, so do you see anything here? Yeah, right here. That kind of looks like a nested list, but it isn't because I've got something in here called name. I don't have 0, I don't have 1, I have a name. Ooh, when you start to have names, this is no longer a list, this is a dictionary. Those are much easier to work with. Okay, there you go. There's absolutely nothing. Let's see, expose and find flapping. Okay, here we go. That has a bunch of tabular data. Let's take a look. Do we see anything? Um, yeah, there we go. No, 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 no. Oh, I see rows. So maybe I'm using one right here. Oh, look, I am using one right here. It does happen. Okay. Do I use it all the time? And the answer is no, not really, but here you go. Yeah, it happens. This particular program had a lot of data that was in a two-dimensional list. Okay, it was literally a nested list that I read in. Did I like it? No, I didn't. Because what I had to do is I had to go through and I had to look for the course name and I had to count out how many columns over, and it was 80 columns. It's a huge database that I was pulling in. So these types of things do exist, but I'll be honest, they're pretty minimal. As I said, in your data science course, you will see a lot of data like this, but the first thing you do is you usually turn it into something that's much easier to work with. In fact, that fine flapping, this is exactly what I'm doing, is I'm turning it into something that's much easier to work with because these two-dimensional lists are really quite something. All right, that was the final slide, I think. To get back over to here. Yeah, that was the final slide. All right, so I have one thing that I want to talk about. All right, so it took me a while, but the good news is somebody gave me an answer to something. Give me a second because I can't show you everything. All right, so there was questions about, okay, what does the final exam in this course look like? And I was given the following. Okay, so here we go. This was the final exam from last time. Now, I'm not going to scroll down and show you the questions. Sorry, I'm not allowed to do that. But I do have a practice exam that was given to me, but it just isn't here. It's in my email, so I'll just have to pull it out. I will make that available, I guess, tomorrow. Yeah, probably tomorrow at the end of class. I'll make that one available for you. But at least you can see what the format is. So for this, there was 10 multi-choice questions. There were 5 fill-in-the-blank questions. These questions here were basically, what's the output of this program? Okay, hey, you know what? We can do one right now. Do print test scores at 2, 0. All right, and I could say, what's the output of this program? Okay, and these are the types of things. It might show up as a fill in the blank, might show up as a multi-choice question. So, of course, to be able to do this, you'll have to realize that, okay, I've got an array of arrays, and we're talking about list number 2, that's 0, that's number 1, that's number 2, and I'm talking about the very first element, that will be Fatma. Okay, so those are the types of things we get for multiple choice and fill in the blanks. There's a couple of interesting questions. They were called debugging questions. I had to go look and see what they meant by it. What it is somebody said, okay, here's a piece of code, and the question was, what's wrong with it? And somebody had to go and say, oh, we're missing this, we're missing this, maybe we're missing an ending quotation mark. Of course, we wouldn't color it to make it stand out, but that's what the debugging questions were about. Okay, it was go and look at some problems and tell us where the problems are and how you'd fix them. All right, and the final one, there was 3 short programming questions. They were actually really, really short. I think they were too short personally. I would have liked to have seen slightly more complex questions, but hey, the good news is if somebody else has done something already, it means that I'm not going to deviate too much from it. All right. Now, you can see here, obviously, there was a place here for people to write things. Because you guys have access to D2L, and again, it's very, very important you get your access to D2L. I might put the quiz on D2L because I don't like having paper type stuff. I don't find programming on paper is all that great. I would rather have you guys be able to type things or be able to click on solutions. It's quicker for me to grade. It's a little quicker for you to write. There's less problems. And if I give you access to the online interpreter, it means that you can actually try your programs to make sure that they're correct before you submit them. Okay. All right. So I will probably not put it on paper, but I will put it in this format. So as I said, I've got a sample exam. I will make it available tomorrow. Okay, so not this one, zip, because I'm not sure how much different things will be. But I will certainly give you the sample one that was given last time as well. And if I need to make a change to it, maybe I add a couple of extra questions to make it a bit more challenging. I'd rather give you guys a challenging practice and then give you an easier final. Rather than the other way around. That's quite disturbing if you get a really easy practice and then the final is more challenging. Okay, but in any case, that's it. So that's the format. I certainly don't have a time for the final exam. All I have is still the date. And I don't even want to ask because nobody's going to tell me yet. They're going to say, we'll figure that out a bit later. Okay, so I don't think there's a reason to ask. What I do want you to do is I want you to continue to take a look at the news items in D2L. So let's pull this up over here. Okay, now let me check and see if everybody's in place. Okay, I'm still got 3 people who have not logged into D2L. Make sure to get this set up if you haven't. But in any case, what I want you to do is, even after we're finished the class, just pop open D2L occasionally and just check and see if there's a news item in here. When I get information about the timing, I will post it here as a news item. I'll probably send it by email as well, but your email will be the university email, not your personal one, because I don't have access to that. But just come back here occasionally and check things. All right, just as a reminder. Okay, I've uploaded lecture number 7, 8, and 9. These are the ones that I covered today about variable scopes, the basic lists and the nested lists. We have got the YouTube playlist. I will upload this video before I go, and I'll make this available. Once you click on this and go over to the list, you will see, well, you'll see all 3 of them once I put up the next one. And of course, we've got the lab exercises. And let me pull up the lab exercises so that I know exactly what we've got. And I can tell you which ones are probably most important. Don't worry, I'll drag it over in a second. Just trying to find the folder first. Enter. Okay, here we go. This is the content of the zip file. Okay, so we have seen enough up to functions, no problem. Here we go. Lists, definitely. Okay, and more lists. Okay, I better take a look at this and see what's in here. Okay, online interpreter, that's just more lists. So those are just regular lists. But there's a little bit of two-dimensional lists as well. So yeah, that's fine. That's fair game. Let's see, week number 8, nothing. Week number 9, sets and tuples, no. Okay, so not exercise set 7. So exercise 5 and 6. You will, of course, notice that there's not very many nested lists in here, and that kind of matches what I said. They're not really used that often. If you have a lot of complicated data, you'll probably find that a dictionary is considerably better, which is something that we'll cover like next. Well, we'll cover sets and tuples first, then dictionaries. Dictionaries and lists of dictionaries, those are the most important things. These are the things that I use all the time, and they're things that everybody uses. All right, so perfect, 6:49. That's exactly the time that I wanted everything to finish. So I think we ended up doing all right for this time. All right, so what I will do, I will stop the recording so I can start the download.